Okay, fine. So yesterday, last 2 days we were looking into the client-side profiling and client-side optimization. So just for the people who have joined new, right? The overall, when you look into the end-to-end performance testing, or from an end-to-end interaction, right? You open a browser, you do something, the request go to the server side. So when it comes to engineering, we'll be looking into the both the side of it. One at the browser side, and second at the server side, right? And from a server side, there are a lot of things to look into it. Right from your CPU profiling, memory leak analysis, GC analysis, heap dumps, thread dumps, GC tuning, JVM benchmarking, DB analysis. There are a lot of things that you look into from a engineering aspect of server side. And when it comes to the browser side, client-side profiling and client-side optimization is the one which you will do from a end-user experience, right? So what we saw last 2 days is on the client-side profiling, client-side optimization. Okay. Now, so again, the client side is going to be independent, or is going to be not depend upon whether the backend is going to be Python or Node.js or Java. The client-side profiling and optimization is going to be pretty much same, right? Because your front end is going to be comprising of your style sheet, JavaScript, your document, XHR calls, images, videos. So irrespective of the backend technology, your front end is still going to be profiling, and optimization is going to be pretty much same. Okay. Now, as I was mentioning on the first day, right? Before going into the server side aspect of engineering, we'll just spend some time on the some of the concepts of JVM and Java. Okay. Again, the main reason for that is things should not be a black box for you, because when you go and talk to the developer about the performance issue, when you're going to say that there's a problem with your method, there's a problem with your class, or there's a object which is having a leak, right? It should not be something you go and talk about with some terminology, right? You should be clear in your view how what it is you're talking, and you should be able to visualize that as well. So it should not be a black box. From that perspective, we'll spend some time on these basics. Okay. Um, Now, so I was telling you that one of the prerequisites that should be there in your mission is going to be your Java, right? And in Java, you have when you install Java, right? You will have the entire Java development kit, JDK. Why the slide is still loading? Just give me a few seconds. Let me try it again. Slideshow. Yeah. Okay. So you will come across these terminologies: JDK, JVM, JRE, right? JDK stands for Java Development Kit. JVM is your Java Virtual Machine, and JRE is your Java Runtime Environment. Okay. If you want to keep it very simple, the entire when you install Java, all these things are going to be part of your folder structure. Okay. JDK is a superset. JDK will comprise everything, as you see it in the box here, right? JDK comprises of JRE plus compilers, debuggers, and Java document. The JDK will have everything for you to develop, compile, build, debug, execute. Everything will be part of your JDK. Okay. And JRE is a Java runtime environment. Okay. So not see wherever you're going to deploy your application. Okay. It's not a development environment. It's more of your, say, production environment where your application will be deployed. In that, you don't need a JDK, right? You just need a JRE. You just need a Java runtime environment. Okay. And Java runtime environment, as the name says, it will have libraries for running your Java application. It's a runtime environment. Okay. And inside Java runtime environment, you're going to have JVM, which is nothing but your Java virtual machine, which is actually going to execute your code, and some of the native class libraries. That's how it is going to be. Okay. Now, to keep it very simple, as I said, if you go to your Java directory, Okay, wherever you have installed Java in your machine, if you go to Java program, C program files and Java, you will see a JDK, and inside JDK you will see bin, and then you will see java.exe. Okay, and then inside JDK, if you'll also have a JRE. Okay, and inside JRE, if you go to the your bin, you will have for server, you will have a JVM. Okay, so from a installation perspective, it's end of the day, it's all files and folders. From a usage perspective, you need JDK for all your development and your compilation, building your application. For hosting your application, for deploying the application, you just need a Java runtime environment. Okay. Now coming to your mission, right? I was asking you to have Java installed, and it can be anything. If Java 8 is there, it would be still better, because um, the library software which I'm going to give it, it will be directly compatible. Even otherwise, still it's okay. Okay, so just go to the command line in your mission, in your wherever you're going to practice, and then type in Java version. Okay, so it will show 1.8 or whatever, depending upon that is there in your mission. Okay, if it is not showing, in case you have installed Java, but if the version is not showing up, go to the environmental variables. Okay, go to this environmental variable. Okay, and then you should have this Java home with the directory. Okay, wherever Java is installed, that directory. And then if you go to the path, in the path also you provide the JDK path. Okay, so these things are the one which will make your Java to be recognized in your machine. When you open Eclipse, when you open Tomcat, when you open even for Jmeter, right? Jmeter also require Java. So for all these Java-based application, you need this runtime environment. Okay. Now, okay. Now, when it comes to your, so I talked about JDK, JRE, and inside that there's a JVM, correct? And JVM, as I said, it's a Java virtual machine. It you create your Java program, and then when you compile it, it becomes a class. I'll talk about class, object, everything today if you have time, or maybe on Monday. Okay, so you create a program, you compile it, and then when it is going to get loaded into a JVM, JVM will execute that code, and then it is going to give an output. Okay, so which means you create your programs in Eclipse or any IDE, and then you compile it. Okay, and then that compiled program will get loaded into the JVM. Okay, when we are going to say, for example, I showed you the WAR file, right? When I copy that WAR file into the Tomcat, and when I start my Tomcat, all the classes in that inside that WAR file will get loaded into the through this something called class loader, right? In JVM architecture, if you see, the first thing is going to be a class loader. So it is going to load all the classes part of your application. Okay, that's not an important component for us from a performance engineering perspective. The class loader is just a component in JVM. We don't need to really worry how it works. Okay, the JVM memory is going to be a very, very important component in your JVM. Okay, I am keep saying it. In any engineering, your ultimate objective is to optimize your memory, optimize your CPU. Okay, that that's a very basic goal of any engineering. Okay, now within JVM, right? As I said, JVM memory is going to be a very important component, and the JVM memory is split into 5 subcomponent. Okay, you have heap, stack, PC register, you have native stacks, and then you have something called metaspace. The method area, whatever you seeing it here, it is not in scope now. It is replaced with something called metaspace. Okay. Now, in this 5 components, again, we are not going to really worry about PC register, native method stack, meta space. All these 3 components are, we will not, mostly we will not monitor, we will not configure, we will not tune, and not much problems are going to be with this component at all. Only one component which is going to have problems, which we have to configure, which we have to monitor, which we have to analyze, and there will be problems we are going to troubleshoot, is around the heap. Okay, so there are two. Second component is going to be stack. These are the two things more important from various aspect of your the way application is going to work. Okay, so I'll spend a little bit of more time on these two things. Okay, the heap and stack. Yeah. If you take any Java program, we'll write some program as also today or Monday. If you take any Java program, you need some variables to be declared. Correct? Any program, even if you take a very simple calculator program, you have to do an addition. Okay, so A plus B is equal to C. So you have to declare A, you have to declare B, and you have to declare C. Right? So A can be an integer, B can be an integer, C can be an integer, and for some other calculation, for some other processing, you will declare all these strings or arrays, everything. Correct? Now, the stack and heap, these are the two important components within JVM memory. Uh, in Java, there is something called primitive data type, non-primitive data type. Don't even get confused with these terminologies. It's not really important for us. Okay, I'm just giving some examples so that you will not remember. Okay, all the primitive data. Primitive data is nothing but all the small data types, integers, characters, boolean, all are very smaller in size. Okay, non relatively, it don't occupy much space. All these are called as primitive. Okay, and these will get stored in a space called stack memory. All the relatively larger uh, variables, strings, arrays, you create objects. We will talk about objects now later. Okay, I'll maybe today or Monday. All these are called as non-primitive, and it will go and sit in the heap. Okay, and so that's a basic difference between stack and heap. In a program, in a single program, I will declare integer, I will declare string. I will also create some objects. Object strings will go and sit in the heap. Integer will go and sit in the stack. Okay. The variables that are sitting in the stack will get deleted by itself once that execution is over. As addition calculation, addition functionality is called A plus B is equal to C. When A plus B is equal to C, processing is completed, all A, B, C will get deleted immediately. Okay, there is no condition, it will get deleted immediately. Whereas when you declare a string or an array or object, it won't get deleted immediately. Your JVM have to run a garbage collection, then only it will get removed. Okay, that's again a difference. You will learn more about this in the upcoming sessions, but from a basic difference between heap and stack, that's how it is going to work. Okay, now there's one more additional thing that you need to remember. For every variable that is getting stored in the heap, there will be a mapping to a stack with an address. Okay, an address or a reference. See, if you create a string, if you create a array, for every such a variable creation, there will be an address that will get stored in the stack. See in this diagram, okay, right hand side, there is an object or an array. And then there is an arrow mark with a dot. Okay. So when I create a string, there will be an address stored in the stack. It's like I will give an example. Say for example, if you're living in a say Mumbai, okay, and you have 1,000 square feet apartment, okay, and then an apartment will have an address, right? It can be an Andheri, some kind of apartment name, some apartment number, road, street name. All these things are going to be there, and pin code, correct? So the actual size of an apartment is 900 square feet or 1,000 square feet. That's an actual size, and it will have an address, correct? Without an address, nobody can reach it, correct? Similarly, here every object will have 1 MB or 500 KB or 20 KB or 30 KB. Okay. And then the address of that, okay, will be there in a stack, and there will be a connection. Okay. So there is a lot of things behind this. For garbage collection and all, these relationships are very important. Okay. I will not go in detail. Let's keep it very simple, basic for now. There are two important components in JV memory. Those are heap and stack. And stack is going to store integer Boolean character. And then your heap is going to store your strings, arrays, and objects. Whatever that is going to get stored in the stack will get deleted immediately. Whatever that is getting stored in the heap will have to be removed by a garbage collection. And for every strings or object that is going to get created in the heap, there will be a reference or an address that will get created in a stack. Okay. And from a configuration perspective, say we go and configure heap. Okay. XMS and XMX. We give 2 GB, 4 GB, 3 GB. So we will configure the heap. We'll monitor the heap. That will be a problem. We will go into a leak analysis. We'll go into a heap dump analysis. All these things we'll do it from a heap perspective. A lot of things we'll learn also. But stack, you don't see normally a lot of problem at all. I mean, you will know why later. But stack and all, we'll hardly will monitor or hardly will go and configure. We by default the whatever memory JVM gives to stack, that'll work. Okay. So mostly we will not touch the stack mostly. Okay. And other components are not really important for you to understand, but from a definition perspective, when you declare a static variable, okay, in your application, that will go and sit in your meta space. And all the metadata about your classes, all the classes, their definition, okay, all this metadata about your classes will be there in the meta space. And again, you won't configure and you won't monitor. We will not even touch it. Okay. PC register, as the name says, it's a registry. It will just keep a note on what threads are running. Thread is what activity a thread is doing. Just a registry that is getting maintained within your JV memory. Again, we will not even worry about it. We will not even touch about it. Okay. The next one is going to be your native method stack. As a name says, it's a native. Okay. When your Java component is going to interact with some of your Windows components, some other Windows program, maybe a Python desktop application is running. So whether it is going to interact with your Windows component or desktop components, that interaction, whatever that is memory required for maintaining that connection, that will be there in your native method stack. Okay. Again, we will not really worry about anything at all. Apart from heap, sometimes stack, only these two we are going to worry, or we are going to look into it in detail from a learning, also from a project perspective. Okay. And then, so apart from JVM memory, of course, your JVM is very the actual work is for the execution, right? It has to execute your Java code. Okay, so the other components are going to be your execution engine, which is actually going to execute your, which is going to actually see whatever when you deploy the your Java code, right? And when it is going to run, your execution engine will convert your Java, we call as bytecode. Okay, it will convert that into a machine understandable code, and then it will get executed. Okay, so execution engine will take care of converting your Java uh, bytecode to a machine understandable code, and it will go on execute it. Okay. In fact, within your execution engine, right, there are a few components which is not really important apart from GC. Okay, your garbage collection is a component of your execution engine. Okay. Um, Actually, garbage collection, if you look into it in a very simplest way, it's a set of folders, set of files, set of libraries. Underneath it, by itself, it's a code. Garbage collection is an algorithm code, which will actually keep running behind the scene to clean up your heap. Okay, so garbage collection is a component within execution engine, which we will learn a lot. We have to monitor. We have to probably sometime tune. All these things are required from a garbage collection. Okay, this interpreter, JIT compiler, hotspot profiler, and all, it's part of your actual execution. It will convert into a machine understandable code. It will execute. All these things will be taken care by these three components, and we will not even monitor what an interpreter is doing, what a compiler is doing. No, it's just an execution. These three components will take care of the execution. Garbage collection will take care of your maintaining your heap memory, or clearing the unwanted memory from the heap. Okay, I'll pass it here before I go further. Anybody have any questions? Okay, now when it comes to monitoring and all, how do we monitor this JVM? All these things we'll learn later. Okay, as we go along in the upcoming classes, right? Uh, will focus a lot on heap. As I said, your leak analysis, monitoring the heap, configuring the heap, benchmarking the JVM, and then taking the heap dump, analyzing the heap dump. So, lot of learning will be happening around this heap. Okay, yeah. Now, I was mentioning about these the class and objects, right? Now, what we will try to do is learn Java from a more from as a template. Okay, we're not going to be creating applications, right? We're not going to develop applications or lot of programs. Our intention here is to understand what is this class, method, objects uh, in a simplest way, not in an accurate way. I'm not going to explain you in a very accurate way. That will be a more complicated, complex, and it will confuse us. Okay, we will try to understand it in a very simple way so that you will not forget, and then you can relate it during your engineering analysis. Okay, now if you guys have worked on LoadRunner, right? A LoadRunner will have a template, correct? It will have an init, it will have an action, and within action you will have multiple transactions, and then you will have user end, right? Similarly, Jmeter will have some structure, some template which means for every script, these things are going to be there always. Similarly, if you take Java program or a Java application, a small application or a huge application, enterprise application, everything is going to follow these skeleton. Okay, to keep it in a simple way. When you create a program, say for example, if you open the Eclipse. Okay. And then if I go to the source, Now, if you see, here it's a Java program, right? So a program, when you type in, it's you want to save it as a .java. Okay. It can be simple addition program, reading a file, writing a file, anything. So when you compile this Java program, okay, you will have a class file created. Okay, you will have a class file created. Class file is a compiled version of your actual program. Okay, so class is nothing but a program by itself, a compiled version of a program. Okay, within your in your any application, you will have multiple programs or multiple class files. Right. So, for example, if I go to our e-library application, okay. So e-library application, we saw the web application, right? And this is the code behind it. If I go to e-library and go to the Java resources, if you go to the source, okay, and if I go to this, you will have a lot of Java files, correct? And every Java file will have a associated class file, okay. And then if you see, all these Java files are grouped into com.javapoint.servlet. It's a package, okay. It's kind of, you can just say that it is a folder inside a folder you have all these files. So any Java application, it's going to have one or more package, and each package will have one or more class file. If you see here, there are 3 packages, okay, 1, 2, 3, and inside a package there can be multiple Java files or a class file. Inside this, there are again a lot of class files. So an application can have multiple packages. Each package will have multiple classes, and inside a class or inside a program, okay, you will have multiple
Hello.
one or more methods.
Hello. Hi, Satish.
Yeah, hi.
Hi. Sorry for interrupting, but your video is lagging behind your voice, and
Oh,
also
really?
voice is
Okay.
yes, voice is breaking,
Oh, one second. Let
and like
me.
video is also like your mouse is not smoothly going. It's like sometimes here and when you do something else, it goes directly there.
Okay. Let me do one thing. Like, let me try to. Is it for everybody? I'll try to switch my network actually. Okay, I have switched my network in my mobile. Is it okay now? Let me continue. That you please let me know. Okay. Um, you guys able to hear me?
Yes.
Okay. I have again joined back. In the audio at least. You guys able to hear me
Yes.
properly? Okay. 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 Fine. So what I was saying is, a Java program is going to have one or more package. Okay, and a package will have one or more class files. And in every program, you can have multiple methods. Okay, you guys able to see my Eclipse now?
Yes.
Okay, 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 okay. So in any program, right? You will have one or more methods. Method is nothing but a it is a one which is going to have an actual code for your execution. Say, for example, in a calculator class file, you can have a addition program. You can have a subtraction program. Let me go to that as well, so that it will be easy for you to visualize it. Is that, yeah. Okay. See, for example, here there is a method for addition, method for subtraction, method for multiplication. So a class file can have multiple methods. Method is nothing but a actual lines of code which are going to be there for some processing. So anything. It can be a code for connecting to a database. It can be to read some files and write some files. Actual activity is going to be there inside a method. Okay. A class file will have multiple methods. Okay. And a class file will also have a variables, as I said earlier. Okay, so any program, if you take it, it will have packages, multiple packages, and a package will have multiple classes. A class will have multiple methods, and a class will have declarations, variable declarations. It can be primitive or non-primitive. Primitive are your small variables like integer, byte, character, boolean. Your non-primitive are going to be your strings, arrays, and objects. Okay. Now, okay. Again, we will do some programming on Monday as well, so that it's not hardcore programming, but some simple programs, so that you will know how a method, how you can call one class file from another class file, how we are going to call it, how we are going to connect to a database, how we can connect to a third-party services. Because all these things, right, when you do an analysis in your APM tools or your profiling tools, right, in an enterprise application, you are going to have multiple components, multiple APIs, multiple classes. Your for any functionality, a functionality will call a first class file. From first class file, the control will go to class another class file. From there, it will call a DB, and then it will come back to class B, and then it will come back to class A. So that's how it is going to work. Multiple classes are going to be get involved for even for a one single functionality. Okay, so from that perspective, we will try to create some programs so that you will be able to always visualize it. This is how a program is going to be. This is how a method is going to be. This is how a one class file is going to be called from another class file. That understanding alone is more than enough for your from my engineering perspective. Okay, now this object. Okay, the definition of object, you would have seen it in many places. Again, I will not go more from a book way of explaining it or a correct way of explaining you it. I'll just keep it simple so that you will not forget. Okay. I'll give an example. Okay. You will we all use Amazon.com, right? So you open your Amazon.com and you wanted to probably purchase a mobile. Okay. You search for a mobile, and then you found a mobile variant which is something you're looking for, say a Samsung some model, and then you add it to a cart, and then you want to check your price, right? The price will include your discounts, will include taxes. So you wanted to calculate a price for your mobile. Okay. Same way, I am from my laptop, I am trying to purchase a laptop. Okay. From my mobile or from my laptop, I'm going to Amazon.com and I'm searching for a, say, a Dell laptop. Okay. And I also wanted to know my price. Okay. Now, in Amazon.com server side, there will be a service or a class file for calculating your price. There will be only one class file, right? Now, in runtime, you hit a button for price calculation. I also hit a button for price calculation. The call will come to your server. At the runtime, okay, at the runtime, a duplicate of that price class file or an instance of your class, the price class file will be created for you, will be created for me. One duplicate will be for you, one duplicate will be for me. That duplicate copy is what we call it as an object. Okay. Object is an instance or a duplicate of a class file that will be created during a runtime, which means when it is getting created, right? For you, it is mobile, Samsung mobile, and then quantity as say one. For me, laptop, and then model is Dell, quantity is one. Okay, so the object will hold uh, these for you, your JVM will as created an object, and then whatever your requirement of mobile quantity one and Samsung type, all these things will be handled separately, and then the program will get executed, and you will get your price. And for me, it's laptop, Dell, and I'll get a price. Similarly, hundreds of people are going to be in the production doing the similar activity. So which means in the runtime, 100 objects will be created, 1,000 objects will be created, right? Because we are talking about only about the price calculation. There will be a login, there will be registration, there will be a search, there will be checkout. For every activity, wherever the objects are created, it's going to be hundreds of thousands of objects are going to be created, and it's going to be there in the heap. Okay, so object will be created, it will be deleted, created, deleted. That's how it is going to be. So object is nothing but a reference, sorry, the instance or a duplicate of a class file. Okay, so we no need to complicate this any further. There are many correct definitions available. I haven't given you the exact accurate definition, but this understanding is what important. Okay, in runtime, your JVM will create n number of objects. It will be stored in the heap, and then it will get deleted. Once the work is over, your these objects will not be required. Your garbage collection will go on delete those objects after some time. Okay. Um, what we'll do on Monday is we'll go and write some programs. Probably you try to install Eclipse also in your machine. Eclipse is also uploaded to the drive, or you can also download the Eclipse. It's just going to be very simple download and unzipping the folder. You will get the Eclipse. Okay, so that on Monday we'll start writing some small programs just for our if you do an hands-on, we will not forget. That's the only reason for creating these programs. Okay. Yeah, I'll stop it here. If you guys have any questions on setting up the Tomcat, setting up the database, starting the Tomcat, deploying the WAR file, if you have any questions, please let me know, because I would request you to do this thing over the weekend, so that from Monday, whenever we are going to do all this engineering learning, you will be able to practice it the next day or in the the other days. Okay. So anybody have any questions on those Tomcat installation, how to copy the WAR file, deploying it? Anybody have any questions? People who have joined new, please go through the videos maybe tomorrow. And if you guys have any trouble, you will have trouble. Don't worry about it. Just try to see what is the problem. And you, from an engineering perspective, from now on, you should always have that open mind of there will be problem, challenges, and it can be solved. You have to spend some time, and with fun, you would be able to easily solve it. Any software installation, anytime, even if I go to install some software in a new machine, there will be some problem, some compatibility problem, something we would have made a mistake, but you would be able to solve it. So install Tomcat, install Java, and then install MySQL. Follow the video that is already uploaded. If you see in the video playlist, there will be 14 minutes video for a Tomcat. There will be 6 minutes video for a database setup. So follow that. If you guys have any problem, just message it in the WhatsApp group. We'll try to provide you the uh, uh, clarification or solution over the chat itself. Okay.
Hello. Hi, Satish.
Yeah. Hi.
Yes. So on the first day, you told that this course is from basics to intermediate, right? So, like, do you also take intermediate to advanced for performance engineering?
We were planning one, but I don't know when it is going to happen. Next 3 months, I think we already have the schedule packed. So next 3 4 months, I don't think we are going to have anything on intermediate to advanced.
Okay. Okay.
Yeah, 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 yeah. Okay, fine. Fine, guys. Then I think you take time over the weekend to please do all the setup, and then we'll connect on Monday. Okay. And people who haven't registered or made payment, if you guys have any questions, clarification, or do let me know. We can connect tomorrow. Yeah. Yeah. Thank you, guys.
Thanks. Thank you.
Yeah. Thank you. Yeah. Have a good weekend, guys.